Well, let me tell you about a man named Carl Sagan who once said something that has stuck with me for a very long time. He said the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. And that is a beautiful thing to say. But here is what he did not tell you. When you are cremated, when your body is placed in that chamber and heated to 1400 degrees Fahrenheit, not a single atom of that star stuff is destroyed. Not one. Your body breaks down, yes. The pattern that was you disappears, yes. But every atom continues. Every single one. And where those atoms go, what happens to them in those 2 to 3 hours inside that chamber, that is what I want to tell you about today. You see, this is not some abstract idea about the afterlife or souls or anything like that. This is physics. This is the first law of thermodynamics, which says very clearly that matter and energy cannot be created or destroyed, only transformed. And cremation is one of the most dramatic transformations your body will ever undergo. It is the moment when the pattern called you ceases to exist, but the atoms that made you scatter to the winds, literally. Some of them will become part of the air, some will settle as dust, some will remain as powder in an urn, and every single one of those atoms has a story about where it goes next. Now, to understand where your atoms go, we first have to understand what you are made of, and I mean really made of, at the atomic level. The human body contains approximately 7 times 10 to the 27th power atoms. That is 7 octillion atoms, 7 with 27 zeros after it. An almost incomprehensible number. And these atoms are not evenly distributed among different elements. No, no, no. Your body has a very specific recipe. 65% of your mass is oxygen. Not oxygen gas that you breathe, but oxygen atoms bound up in water and in all the organic molecules that make you work. 18% is carbon, the backbone of every organic molecule in your body. 10% is hydrogen, mostly in water but also in fats and proteins and DNA. 3% is nitrogen, mostly in proteins and in your DNA. 1.5% is calcium, almost all of it in your bones and teeth. 1% is phosphorus, also mainly in bones, but also in ATP, the molecule your cells use for energy. And then there are trace elements, tiny amounts of sulfur, potassium, sodium, chlorine, magnesium, iron, and a few others. That is what you are. That is the complete list. 7 octillion atoms, arranged in this very specific pattern, and somehow that pattern is conscious and can wonder about itself. Think about that. Now, when your body is placed in a cremation chamber, the temperature rises to between 1400 and 1800 degrees Fahrenheit. That is between 760 and 982 degrees Celsius. And this temperature is not arbitrary. It has to be hot enough to break down the molecular bonds that hold your body together, but not so hot that it vaporizes everything. You see, different chemical bonds require different amounts of energy to break. A carbon-to-carbon bond, the kind that makes up the backbone of organic molecules, takes about 3000 degrees Celsius to break completely. Cremation does not reach that temperature. It does not need to. Because what cremation does is break the bonds between molecules, not the bonds inside atoms themselves. And here is what happens. The moment the temperature starts to rise, water begins to evaporate. Remember, 65% of your mass is oxygen, and most of that oxygen is bound up in water molecules. Each water molecule is 2 hydrogen atoms and 1 oxygen atom, H2O. At those temperatures, water turns to steam almost immediately. All the water in your blood, in your cells, in your tissues, it vaporizes and becomes gas. And that gas, that steam, it flows up through the chimney and into the atmosphere. Those hydrogen and oxygen atoms that were part of you, that were in your blood just hours before, they are now water vapor in the air. Some of them will condense into clouds, some will fall as rain. Some will be absorbed by plants, some will be breathed in by other people, but they continue, they do not disappear. Now, as the temperature continues to rise, something else starts to happen. The organic molecules in your body, the fats, the proteins, the DNA, the carbohydrates, they start to break down. And what are organic molecules made of? Carbon. Long chains of carbon atoms with hydrogen and oxygen and nitrogen attached. And when these molecules break down in the presence of oxygen and heat, they combust. They burn. The carbon atoms combine with oxygen atoms from the air to form carbon dioxide, CO2. And just like the water vapor, the carbon dioxide rises up and exits through the chimney. This is where the carbon in your body goes. The carbon that was in your DNA, in your proteins, in the fats that cushioned your organs, all of it becomes CO2 and enters the atmosphere. And you know what? That carbon will be absorbed by plants during photosynthesis. It will become part of a tree or grass or a flower. It will be breathed in by animals. It will dissolve in the ocean. It will continue to cycle through the Earth's carbon cycle for millions of years. The carbon atoms that were once in your body will be in thousands, millions, billions of other living things over time. They do not stop being useful. They just stop being you. The nitrogen in your body, mostly in your proteins and DNA, it also becomes gas. At cremation temperatures, nitrogen bonds break down and nitrogen gas, N2, is released. Nitrogen gas makes up 78% of Earth's atmosphere, so those nitrogen atoms just rejoin the vast reservoir of nitrogen in the air. Eventually, they will be fixed by bacteria in soil and become part of plants again, then animals, then maybe another human being. The nitrogen that was in your DNA, coding for every trait you had, will one day be in someone else's DNA, coding for traits you will never know about. But here is where it gets interesting. Not everything becomes gas. Some atoms in your body have much stronger bonds, bonds that do not break at cremation temperatures. Calcium and phosphorus, the minerals in your bones and teeth, they remain solid. They do not vaporize. They do not combust. What happens instead is that all the organic material around them burns away, and what you are left with is bone mineral, mostly calcium phosphate, along with small amounts of other minerals. And this is what people call cremated remains or ashes, though they are not really ashes in the way we usually think of them. They are bone fragments ground into a powder. And this powder, these cremated remains, they weigh between 4 and 8 pounds for an average adult. Think about that for a moment. You start with a body that weighs, let us say, 150 pounds. After cremation, what remains is 4 to 8 pounds. Where did the other 142 to 146 pounds go? Into the air, as gas, as water vapor and carbon dioxide and nitrogen gas. The vast majority of your mass leaves the cremation chamber as invisible gas and disperses into the atmosphere. Only the dense mineral structure of your bones remains behind. Now, you might be wondering, why does calcium stay solid when carbon becomes gas? And the answer has to do with the type of bonds involved. Carbon, when it is part of organic molecules, is held together by covalent bonds with other carbon atoms, with hydrogen, with oxygen. These bonds are relatively easy to break with heat. But calcium in your bones is not in the form of simple molecules. It is in the form of calcium phosphate crystals, an ionic lattice structure that is extremely stable. To break those bonds, to turn calcium into gas, you would need temperatures around 5,000 degrees Fahrenheit or higher. Cremation does not reach those temperatures, so the calcium stays solid. And here is something else. The calcium in your bones, the phosphorus, these atoms are ancient. They were formed in the cores of stars billions of years ago, long before the Earth existed. They were part of the dust cloud that collapsed to form our solar system. They were in the early Earth, cycling through rocks and oceans and living things for billions of years before they became part of you. And now, after cremation, they sit in an urn, still solid, still the same atoms they always were. And one day, if those remains are scattered or buried or dissolved, those calcium atoms will become part of the earth again. They will be taken up by plants, by animals, by future humans. They do not end, they just change form. You see, this is what the first law of thermodynamics tells us. Matter and energy cannot be created or destroyed, only transformed. And that is exactly what cremation is. A transformation. The arrangement of atoms that was your body is disassembled. The pattern is destroyed, but the atoms themselves continue, every single one. And this is not a metaphor, this is not poetry, this is physics. Now let me tell you about a physicist named Richard Feynman who thought a great deal about atoms and what they mean. He did not talk specifically about cremation, but he talked about something related. He talked about how atoms move through living things, how the atoms in your body right now are not the same atoms that were in your body 7 years ago. Your body is constantly taking in new atoms from food and water and air, and constantly shedding old atoms through waste and breath and sweat. The pattern stays the same, more or less, but the atoms are always changing. He said that the atoms that make up everything we see, including our own bodies, were once in stars. And now I am telling you that after cremation, those atoms will be in other things. Other stars? No. But other trees, other animals, other people? Yes. And you know what? I think this is beautiful. Not in a sentimental way, but in a physical way. The universe does not waste anything. Every atom is conserved. Every atom continues. The pattern that was you, the arrangement of those atoms that gave rise to your thoughts and memories and personality, that is gone. But the atoms themselves, they are immortal in a sense. They have existed for billions of years, and they will continue to exist for billions more. Now, let us be specific about the numbers, because numbers make this real. An average adult body contains about 7 times 10 to the 27th power atoms. After cremation, the water vapor released contains roughly 65% of that mass, so about 4.5 times 10 to the 27th power, hydrogen and oxygen atoms entering the atmosphere as steam. The carbon dioxide released contains about 18% of your original mass, so about 1.26 times 10 to the 27th power carbon and oxygen atoms. The nitrogen gas contains about 3%, so roughly 2.1 times 10 to the 26th power nitrogen atoms. And the cremated remains, the bone ash, contains about 1.5% calcium, 1% phosphorus, and trace amounts of other elements, totaling around 3 to 4 times 10 to the 26th power atoms. Do the math. All 7 octillion atoms are accounted for. Not one is missing, not one is destroyed. They are just in different places, in different forms. And here is something practical. Crematoriums have filtration systems to capture some of the particles and gases, but they cannot capture everything. They cannot capture water vapor. They cannot capture carbon dioxide or nitrogen gas. Those molecules are too small, too light. They pass right through the filters and exit into the atmosphere. So when someone is cremated, their carbon atoms, their hydrogen and oxygen and nitrogen atoms, they spread out. They mix with the air. Within days, some of those atoms will have traveled hundreds of miles on the wind. Within weeks, they will be all over the region. Within months, they will be scattered across the continent. Within years, they will be everywhere. And this is true for everyone who has ever been cremated. The atoms from every cremated body in history are still out there cycling through the environment. Some of them are in you right now. You have breathed in atoms that were once part of people who lived 100 years ago. You have drunk water that contains atoms that were once in the bodies of ancient humans. And one day, atoms that are in your body right now will be part of someone else. That is just how it works. That is the reality of being made of atoms in a universe where atoms are conserved. Now, some people find this thought disturbing. The idea that the atoms in their body will become part of other things, that there is no permanence, no final resting place for those atoms. But I find it strangely comforting, because it means you are not separate from the universe, you are part of it. You are made of the same stuff as everything else. And when the pattern that is you dissolves, the stuff itself continues. It does not end. It just becomes something else. And here people get confused. They say, well, if the atoms continue, does that mean I continue? And the answer is no. No, no, no. You are not your atoms. You are the pattern, the arrangement, the specific configuration of those atoms that gives rise to your consciousness and identity. When that pattern is destroyed, you are gone. The atoms are just atoms. They have no memory of being you. They do not carry your thoughts or your personality. They are just matter, following the laws of physics, cycling through the environment the way atoms have always done. Think about it this way. A book is not the paper and ink. It is the arrangement of the ink on the paper, the pattern that encodes information and meaning. If you burn a book, the paper and ink still exist, transformed into ash and gas, but the book, the pattern, the story, that is gone. Cremation is the same. The atoms remain, the pattern does not. And this raises a question. What does death mean at the atomic level? Because from the perspective of physics, nothing really dies. Atoms do not die, they just rearrange. A living body is a highly organized system with atoms arranged in very specific patterns that maintain themselves through metabolism and cellular repair. Death is when that self-maintenance stops. The patterns start to break down. Decay begins. And cremation is just an accelerated form of that breakdown. Instead of taking weeks or months or years for bacteria to disassemble your body, cremation does it in 2 to 3 hours with heat. But the end result is the same. The atoms that were in a highly organized living system become part of the less organized environment. The carbon becomes CO2. The hydrogen and oxygen become water. The nitrogen becomes nitrogen gas. The calcium becomes mineral dust. And the second law of thermodynamics, which says that entropy, disorder, always increases in a closed system, that law is satisfied. Your body, which was a low entropy, highly organized system, has become high entropy, disorganized atoms scattered throughout the environment. And you know what? This is how the universe works. Everything that is organized eventually becomes disorganized. Every pattern eventually dissolves. Stars burn out. Mountains erode. Living things grow old and stop functioning. And all of it is just atoms rearranging themselves according to the laws of physics. There is no exception for human beings. We are not special in that sense. We are made of atoms, and atoms follow the same rules everywhere. Now, let me tell you something else. The atoms in your body have been part of countless other things before they became part of you. The carbon atoms in your body, they might have been in a dinosaur once, or in a tree that grew during the time of the Roman Empire, or in the ocean, or in the atmosphere, or in a rock deep underground. Those atoms have been cycling through the earth for billions of years, becoming part of living things, then non-living things, then living things again. And they will continue to do that long after you are gone. There is a calculation that gets made sometimes, a kind of thought experiment. If you take the number of atoms in a human body, about 7 times 10 to the 27th power, and you compare that to the number of atoms in the atmosphere, about 10 to the 44th power, and you assume those atoms mix thoroughly over time, then statistically every breath you take contains a few atoms that were once in the body of Julius Caesar or Cleopatra or any other historical figure you can name. And the same will be true for you. 100 years from now, 1,000 years from now, your atoms will be in other people, and they will not know it. They will breathe you in, drink you, eat you, without any idea that those atoms were once part of a person who lived in the 21st century. And that, I think, is beautiful. Not because it means you continue in some meaningful sense, but because it shows how deeply interconnected everything is. You are not a separate thing. You are a temporary pattern in the flow of atoms through the universe, and when the pattern dissolves, the atoms flow on. Now, there is one more thing I want to tell you. The temperature required to actually destroy atoms, to break them down into their constituent particles, is not the temperature of cremation. It is not even the temperature at the surface of the sun. To break apart a nucleus, to split an atom into protons and neutrons and electrons, you need temperatures on the order of millions or billions of degrees, the kind of temperatures that exist in the cores of stars or in nuclear explosions. Cremation reaches 1800 degrees Fahrenheit at most. That is nothing compared to what it would take to actually destroy an atom. So when I say not a single atom is destroyed during cremation, I mean it literally. The atoms are exactly the same after cremation as they were before. Same number of protons, same number of neutrons, same number of electrons. The only thing that changes is how they are bonded to other atoms. The molecules break apart. The atoms remain. And this is the great insight of chemistry and physics. Atoms are conserved. In every chemical reaction, in every physical process, the atoms you start with are the atoms you end with. They just rearrange. And life and death and cremation, all of it is just chemistry, just atoms rearranging according to predictable rules. So, where do your atoms go after cremation? Into the air mostly, into the water cycle, into the carbon cycle, the nitrogen cycle, into plants and animals and soil and oceans. Some of them stay together as bone ash for a while, but eventually even those will disperse. They will dissolve in rain or be scattered by wind or be buried and broken down by geological processes. And over time, over centuries and millennia, those atoms will spread out across the entire planet. They will become part of everything. And you know, this is not unique to cremation. If you are buried, the same thing happens, just more slowly. Bacteria break down your body and the atoms are released into the soil. They are taken up by plant roots. They become part of trees and grass. They are eaten by animals. They enter the water table. They evaporate and enter the atmosphere. The only difference between cremation and burial is the speed and the immediacy. Cremation releases your atoms into the atmosphere in hours. Burial releases them into the soil over years. But the end result is the same. The atoms continue. And here is the thing, you cannot stop this. You cannot preserve atoms forever in the form they are in now. Even if you tried to seal a body in an airtight container, eventually, those atoms would escape. The container would corrode. The seals would fail. Geological processes would break it apart. Atoms always find a way back into the cycle. Because that is what atoms do. They move. They change form. They bond and bond again. They have been doing this for billions of years, and they will keep doing it for billions more. So if you take one thing from this, take this. You are not permanent, but your atoms are. The pattern that is you, your thoughts, your memories, your consciousness, that is fragile and temporary. But the atoms that make you, they are as close to eternal as anything in this universe gets. They were here before you. They will be here after you. And right now, for this brief moment, they are arranged in a pattern that can think about itself, that can wonder about where atoms go after cremation, that can appreciate the strangeness and beauty of being a temporary arrangement of star stuff. And when the time comes, when your body is placed in that chamber and heated to 1400 degrees, those atoms will be released. The carbon will become CO2 and feed plants. The hydrogen and oxygen will become water vapor and fall as rain. The nitrogen will rejoin the atmosphere. The calcium will remain as dust. And all of it, all 7 octillion atoms, will continue their journey through the universe, just as they have been doing for billions of years, just as they will do for billions more. That is where your atoms go. That is what happens. And that, I think, is a kind of immortality. Not the kind people usually hope for, but the only kind the universe offers. The atoms continue. The pattern does not. And somehow, knowing that, understanding that, makes the pattern feel more precious. Because it is so temporary. Because it will not last. Because right now, in this moment, the universe has arranged itself in such a way that it can know itself, can think about itself, can understand the laws that govern it. And that is beautiful. That is how it works. That is science.